Assalamualaikum and a very good day to everyone. So now we have reached chapter 5, and then this chapter 5 will cover on sound subject, right? And then this is the table of contents, right? We have 7 of subchapters altogether. First we will look into the introduction to sound, but of course sound have also a few different types of sounds, right? We have acoustic, we have MIDI, we have digital audio, and then we also have amplitude and so forth. So after this we will look into it, right? And then next one is digital audio and MIDI audio. So I will briefly explain what is digital audio and MIDI audio. Then after that I will explain briefly on the difference between this MIDI and digital audio. And then next is about multimedia system sounds, and then followed by audio file formats. So as what we have learned previously, which is image have a few type of file formats. Same goes to audio, right? So audio also have its own different type of formats. Then we will look into it after this, right? And then we also will learn on how to add sound to multimedia project. So as we all know, right, there's a lot of software that can be used, right, to create a video and then to include sound in our interactive multimedia projects. So we will learn a little bit on how to include our sound and then how to adjust in a form of how to make the sound become easily to be listened ataupun will be attractive to be listened, right? And then how to make it fade in and fade out, so forth, right? And then we also will learn about sound editing tools that we can use in order for us to edit the sound so that our sound that we use can be matched, right? Can be matched to the video that we will include in our interactive multimedia projects. First and foremost, I will explain about the introduction to sound, right? Okay, sound is actually being produced by the cause of vibrations of things, right? For example, we have our peti suara, we call it as a voice box or larynx, right? In scientific terms, right? Then these vibrations is actually will move into the air, and then these vibrations that move or waves that move into the air have sort of a pressure that will produce sound, right? So that is how sounds are being produced, right? It is actually by the vibrations of stuffs or the things around us, okay? And then the sound waves vary in sound pressure level, or we call it as an amplitude, and in frequency or pitch. And then acoustics is also be used in sound engineering, and then it is terms that also familiar being used in physics subject, right? And then sound pressure levels, loudness or volume are measured in decibels, right? Or in a short form it is called as dB, right? Then same goes to other type of units, like if we want to measure distance, we will use kilometers, right? Same goes to sound. It has its own units, which we call it as decibels, right? So as you can see over here at the bottom of the text, right, we have 1, 10, 100, 1000, and also 10,000. So this is what we call as a decibels measurement scale, right? For this slide, I will explain more on the digital audio, right? So the digital audio data is the actual representation of sound stored in the form of samples, right? For examples, you want to create a video of introducing the facilities that we have in the campus, right? For example, student A will explain about Medan Selera, right? So student A voice recording will become one of the samples, right? Sample number 1. Then for example, next one is student B, and then this student B would like to introduce about PITA, right? Perpustakaan Tun Abdul Razak, right? And then this voice of student B will be kept as a form of samples, which can be categorized as a sample 2, right? So with these samples we will try to keep it, and then we will include it in our video of introducing the facilities that we have in the campus, right? Okay. Point number 2 is about samples represent the amplitude or loudness of sound at a discrete point in time. So meaning to say, when you do the recording, make sure the loudness, right, the level of the volume of your recording is standardized. For example, right, student A is using using the wireless microphone that have noise reduction, for example. So student B, student C, student D also need to use that same, right, the same wireless microphone, so that all the sound will produce in a standard quality, right? And then next one is the quality of digital recording depends on the sampling rate or frequency, that is the number of samples taken per second. And then for your information, right, there are three sampling frequencies most often used in multimedia. And then these three sampling frequencies, we have 44.1 kilohertz, 22.05 kilohertz, and also 11.025 kilohertz. And then these three sampling frequencies uh, considered as a CD quality frequency, right? That usually being used when we would like to produce our video or our interactive multimedia project in a CD, which is a CD-ROM, right? And then the number of bits used to describe the amplitude of a sound wave when sampled determines the sample size. And then digital audio is device independent, so meaning to say we can use any devices that we prefer in recording our audio, right? And then the value of each sample is rounded off to the nearest integer, right, or quantization. And then crucial aspects of preparing digital audio files are balancing the need for sound quality against available RAM and hard disk resources, because different type of sounds, right, different quality of sounds have different size. The higher the quality, the size is much bigger. So that is why we need to identify the RAM of our laptop, of our handphones that we use to record our sounds, right? So make sure the RAM is suitable with the size that we want to record for our sounds, right? Of course, if our video need to use a higher quality of sounds, make sure our RAM is also have the higher capacity, right? And then setting appropriate recording levels to get a higher quality and clean recording as well, right? And as you can see at the bottom of this text, we have different type of frequencies, right? We have original waveform, we have sampling frequency, we have sample data, we have reconstructed waveform, then quantizing or quantization, then we have a quantized wave, we also have original waveform, and then about clipping, we have original waveform and also clipped wave. Okay, once the recording has been completed, it is time for us to edit the sound, right? um, for editing the sounds, right? Voice over, for example, you would like to produce a video for introducing the facilities that we have in the campus, like Medan Selera and also library just now, like I mentioned just now, right? For example, student A would like to introduce Medan Selera Sri Penang, student B would like to introduce library, right? And then these samples of student A voiceover, and then also student B voiceover, we can listen to it from the beginning until the end, and then we will see what the voice that we need, the info that we need, and then which part that need to be removed, we can trim it or we can edit it easily, right? Compared to the if we record the video with the image of ourselves in front of camera, because it will involve facial expression, body movement, and also the combination of our voice. So that part or that type of video is really difficult for us to edit the sounds, right? Compared to the voice of a version of video, right? So the basic sound editing operations have several features. For example, trimming, right? Trimming, of course, kita akan buang, we will remove whatever part that we do not need, right? For example, we have done mistakes in middle, so we can trim it, right? Then we just remove the mistakes one, and then we will merge all the correct or all the sounds that we prefer to be included in our video, right? The splicing and assembly, that is the meaning of merging the sounds or the sample of sounds like I mentioned just now. And then we also have volume adjustment, so which part we need to increase the volume, which part we would like to decrease the volume, that also we can adjust using the sound editing tools, right? For example, when we would like to we would like our viewers to listen to our voiceover narrations uh, more, right? So meaning to say, if we have background music, we reduce the background music volume level, and then we increase, right? We will increase our voiceover narrations volume level so that the viewers can listen to the voiceover narrations um, clearly, right? Because we have reduced the volume level for our background music just now, right? Same goes to fade in and fade out, right? Fade outs, right? Fade ins, usually in the beginning of the video we will use fade ins, so the volume will increase slowly, right, from low level until higher level, right? And then at the end of it, we will usually will edit our sound or our volume of voice or background music from higher or middle level to lower slowly. It will the sounds will be getting lower uh, in a certain level of sound lah, right, to make it more professional, right? Then equalization, so this one is more adjusting in terms of bass, right, trebles and so forth, right? Then time stretching and working on multiple tracks as well, right? And then audio resolution determines the accuracy with which sound can be digitized, right? And then this digital recording, sound digital recording, it have two types. We have monophonic and we also have stereo, and in order to uh, calculate the size, it has its own formula, right? For example, if we can see over here, right, we have sampling rate, right? To calculate the size of monophonic and stereo digital recording size of file, right, we will multiply these three elements, right? First one is sampling rate, will be multiplied with the duration of recording in seconds, and after that we will be multiplied, right, with bit resolution out of 8, right? And then to convert, right, after we have done the calculations, and then we want to convert these bytes or bit resolution in kilobytes, we need to divide it by 1024, right, to make this bit file size to kilobyte file size, right? We done with digital audio part. Now we proceed with media audio, right? Media audio is totally different compared to digital audio, because this media audio is actually the sounds that have been recorded in the software or in any web pages, right? Then this MIDI sound is can be easily download and then keep in our storage like memory card and so forth lah. And then as we uh, listen to any performance, right, like a musicians that usually using keyboard, then these keyboardists, and most of the keyboardists will use this media audio to perform or to conduct their performance, right? So that is why some of the keyboardists, they only just press the keynotes, and then they will use this MIDI background sound or background music to support their performance lah, right? And then for your information, this MIDI is actually a short form of musical instrumental digital interface, right? And then it is required to use a sequencer for software and sound synthesizer, right, in order to create MIDI scores. And then it is not digitized sounds. So like I mentioned just now, right, this MIDI is actually a program, right? The sounds that has been produced earlier and then has uh, has been produced in a high quality of sounds and with a standard format, right? And then this MIDI sounds has been stored as sample sounds in um, any web pages or in any storage or special storage so that people can use it in the future, right? Compared to digital sound, so usually this digital sounds is a raw recording, right? Raw recording of our voice, right? Raw recording of any musical instruments that have been played, right? And then since this MIDI files is small, right, is easily can be loaded at a web page. So I mean to say, if you open a web page, right, the sounds that you will listen, right, on the web page, for example, the home page, right, have the sounds of sape musical instruments that have been converted into a MIDI file format, right? So these sounds can be easily loaded, right? It doesn't takes a lot of times. It can be instantly produced when people or when the user open the home page. So the music will play it along the way, right, easily, and doesn't have any lagging or buffering effects, right? And then the length of a MIDI file can be changed without affecting the pitch of the music and degrading audio quality. So you can change lag, you can trim it without uh, degrading or without reducing the quality of the audio, right? And then working with MIDI requires knowledge of musical theory. So this MIDI is a bit complicated compared to digital audio, because digital audio, all people, the ordinary group of people can easily understand it. But for this MIDI audio, it is requires knowledge of music theory. So in a theoretical part of music subjects, right, we need to know a little bit, or the basic, at least the basic knowledge of music theory, right? And then MIDI is device dependent. So I mean, say, as I mentioned just now, right, MIDI need some sort of device to support or to play the music in uh, in a proper way, right? For example, just now, keyboard. All right. So the keyboard, the MIDI is depending on the keyboard in order to produce the MIDI sounds, right? And then this is just the screenshot, right, of the MIDI software uh, layout, right? So as you can see, we can see the frequency of it. We also have the the equalizations settings over here, right? So that's why if we as an ordinary people or an ordinary individual that doesn't have any knowledge on musical theory, it is really difficult for us to understand this kind of layout, right? So this layout is just for you to see on how this software, a sound editing software for MIDI look like, right? Done with digital audio, and we also have done with MIDI audio. And now we look into the difference between this digital audio and also MIDI audio, right? First and foremost, like we take a look on the MIDI audio, right? MIDI is analogous to structure or vector graphics, while digitized audio is analogous to bitmapped images. So this, I mean to say, this MIDI is uh, more suitable to be combined with vector graphics, but for digitized audio, it is more suitable to be combined with bitmapped images, right? So from what we have learned, right, vector images or vector graphics is something is I mean, the type of image is a simple image like a logo or any other images is not really complicated or complex, right? For bitmap images is something that complicated and then a bit complex. For example, facial expression of a human being, right? The body part of a human being because it has, I mean, the skin's structure, right? The line of the facial expression itself. So that's why digitized audio is more suitable to be combined with these bitmap images. Then another difference is MIDI is device dependent, and while digitized audio is device independent. Okay, so I mean to say this uh, digitized audio or digital audio can be played by using any type of devices, but for this MIDI audio, it is only certain devices that can play this MIDI audio file format, right? Then these MIDI files are much smaller than digital audio. So we need to say these MIDI files can save a lot of storage, right? Because this file is smaller, and then of course you can save a lot of items of MIDI files in your storage, right? And then MIDI files sounds better than digital audio files when played on high quality MIDI device. So as I mentioned just now, right, MIDI is a device uh, dependent, and only certain or specific device can play this MIDI file format of audio, right? So this is why it will sound better if we use that specific device to play our MIDI file sounds, right? Or a MIDI sound file, right? And then next one is MIDI is difficult to play back spoken dialogue, while digitized audio can do so with ease. So I mean to say, if a spoken dialogue, as I mentioned just now, right? Digital audio, we will have or we will record the sounds uh, in a raw, in a raw method or in a raw uh, technique, right? So that is why MIDI is very difficult to play spoken dialogue because it's only can play it, or it is more uh, suitable for us to play any uh, sounds like recording, musical instrument recording. So there is the MIDI file format is suitable for that, right? But for digital audio, it is suitable for voice recording, right? Voice over narrations. So for that, right? Digital audio uh, doesn't have any complexity, right? To play any spoken dialogue playback audio, right? And then MIDI also doesn't have consistent playback quality, while digital audio provides consistent playback quality. And then one requires knowledge of music theory in order to run MIDI, while digital audio does not have this requirement. So meaning to say, right, MIDI is a bit, more complicated and complex because the user of MIDI sound file format need to have at least basic knowledge of musical theory, right? Compared to digital audio, where the user does not have uh, any requirements uh, in basic knowledge of musical theory, right? Moving on the next slide presentations, right? On this slide, we will look into the multimedia system sounds. So as being displayed on these slide presentations, there are few equipments and also items that being used for those interactive multimedia producer, right? First one, we have microphones, right? Microphone, of course, we can use any type of microphones. So this is just the examples, right? Some of the microphones have the noise reduction effects. Some of the uh, microphones also have wireless wireless designs, and then this one is, I think, it is wired designs. And then we also have aux cable over here, right? Of course these aux cables will help us to transfer the micro will help us to transfer the sounds that we produce using the microphone to the laptops or any devices that we would like to store the sounds that we have recorded. And also it will also help us to play, right, to play back the sounds that we have recorded to, by using speakers and any other type of devices, right? We have speakers over here, right? So speakers, sometimes they have these aux cables installed together with the speakers. Then some of it will have or will use the USB port, right, in order to uh, play back the sounds that being recorded on any type of devices such as laptops and also um, mobile uh, digital equipments, right? Then we also have headphones, right, over here. Sometimes the headphones also have its own microphone installed together with the headphones. Then this is the the circuit, right? The circuit that usually being installed on the laptops, for example, and also PC or personal computers. Right? We have line in port. We also have microphone ports over here, the red color one, and then the green color represent the line out or the port that you can connect, right? That you can connect the aux cable. One of the end of this aux cable you can insert it here, and then another one you can insert it on the back of your speaker, right? As I mentioned just now, some of the speaker already have its own aux cable over here, so it will be easy for the user to connect the aux cable to the aux port that available on the laptop or any computers devices, right? We have gaming controller port as well over here. Then for this part we have PCI connectors, right, at the circuit of the card here, sound card here, right? Then for the formats, right, as I mentioned just now, images have few type of formats. Same goes to audio file, right? Audio file also have different type of formats. So for example, over here we have a Macintosh. For Macintosh, such as Apple, right, iPhones or Apple tabs such as iPad, right, and also laptop, right? So usually the sounds that are being stored in Macintosh or Apple products will be saved in AIFF or AIFC format, right? But for Windows, usually the digitized sounds are usually stored as WAV files. So these digital sounds, as I mentioned just now earlier on the previous slides, right? Digitized sounds or digital sounds is raw recording, such as our voice recording lah. So this our voice recording will be saved as WAV files, right? We also have the CD-ROM slash XA, right, extended architecture format, which will enable several recording sessions to be placed on single CDR, right, disk, right, recordable disk. And then we also have linear pulse chord modulation, which usually being used for Redbook audio data files and consumer grade music CDs. We also have MP3 compression. It's a space saver, so meaning to say when we have recorded our digitized sounds in WAV files, so it can be compressed into MP3 file formats, so it will help us to reduce the file size, right? Because the WAV file size is much higher or larger. So let's say we want to save, right, the storage of our computers or our laptop. We can compress it or convert these WAV files into MP3 files in order for us to save a lot of space or the storage space that we have, right, in our laptop or our computer devices. And then MP4 is used when audio and video are streamed together. And then the next or the last formats that displayed on this slide is ACC, which stands for Advanced Audio Coding, and this ACC is usually being used by Apple iTunes Store. Right, next we will touch on how to add sounds to multimedia projects. So as we all know, right, we have a lot of different devices that we use. Some of the people will use Apple products, right, like Macintosh or MacBook, right. Some of the user will use Windows, right, and then that is why we need to know which format is suitable for Apple, right, for iOS, which file format is suitable for Windows operating systems. So we need to properly plan, right? We need to properly plan, right? So that this file format that we're going to use to be included in our multimedia project is compatible with the devices that we use. Same goes to the software as well, right? Make sure the software that we use is suitable with the type of devices that we're going to use, right? Then type of sounds such as background music, right? Special effects and also spoken dialogue must be decided, right? For example, in the beginning of our video, we would like to use background music, so maybe the type of sounds that we're going to use is maybe MIDI is more suitable, right, compared to digital audio, right? MIDI audio is more um, suitable, right, to be used for background music because the size is a bit lower compared to digital audio. Then for spoken dialogue, of course, we're going to use digitized audio or digital audio because it is more suitable, right, compared to MIDI audio. Same goes to sound effects, right? So let's say in the middle of our video, we would like to include some of the sound effects. So make sure you properly decide, right, which file format is suitable to be used for the special sound effect, right? And then create or purchase sources materials. So some of the MIDI uh, you need to purchase it, right, at any MIDI web page or any MIDI sound or MIDI audio suppliers on the internet, right? So make sure you uh, purchase or create any sources, right? For example, like a voice narration, so you need to create it earlier before you um, include it in your video presentation or in your video products, right? And then edit the sounds to fit your project. So edit, like I mentioned just now, so editing, you can play with the fade in fade out effects, right? In the beginning of the video you play with the fade in effects, right? And then at the end of the video you will play with the fade out effects, so that your video and your sounds will display it professionally, right, to the users, right? Same goes to trimming and also merging all the sounds that you have, right? And then test the sounds to be sure they are timed properly with your project. So you make sure that your sound is not exceed the video that you have or any a slide presentation that you have that you include in your video. These are the things that need to be taken into considerations, right? The first one is recording, right? If you do raw recording, of course, you need to make sure that your recording doesn't require a large file, right? Doesn't require large file, especially if your devices have lower storage space, right? So make sure you record your sounds, right, using inexpensive media, right, on inexpensive media rather than directly to disk. Prevents the hard disk from being overloaded with unnecessary data. The next one, the project's equipment and standard must be in accordance with the requirements. So make sure all the equipments that you're going to use and also the file format that required by your clients is being fulfilled, right? So it is vital as well, right, to maintain a high quality database that stores the original sound material, right? A high quality database. So make sure you have or you keep, right, the high quality file format of your sounds, so that if anything happen, if you need to do corrections, right, you can use that high quality original file to edit, right, to do all the editings that you need, right, in order to fulfill all your clients wants and needs, right? And then keeping track of your sounds, right? For example, mobile or web. And then sound and image synchronizations must be tested at regular intervals, right? So as we know, right, when you produce a video and then you combine your video with your sounds, right? Your sound recording, make sure when all the sound recording is synchronized with the image that being displayed on your video, right? Next one, the speed at which most animations and computer-based videos play depends on the user's CPU, right? Computer processing unit, because different CPU have different sound cards, right? Some of the CPU have higher quality or higher model, latest model of sound cards. Some not, some might not, right? So make sure the speed is suitable with the sound cards that you have on your laptop or your CPU. And then the sound RAM requirements as well as the user's playback setup must be evaluated, right? So RAM, right? RAM stands for random access memory. So let's say the computer or the CPU or the laptop have high uh, RAM, right? High RAM capacity. So of course that computer or laptop is suitable for you to use your sounds sound resources with high file size, right? And then copyrighted material should not be recorded or used without securing appropriate rights from the owner or publisher. So you cannot use or you cannot easily use, right, any musics that available on the internet, because a majority, then most of uh, the musics, right, ataupun songs that available on the internet have been copyrighted. So in order for you and your company to be sued, right, by the artist or recording label company, right, make sure the sources of the sounds, or means the songs, the musics that you use is not from the label recording company, right? uh, you can use or you can find any musics or background musics that ever available on the internet that is free copyright musics lah, right? There are some web page have the supplies of these non-copyrighted musics that you can use, okay? And then this is the sound editing tools that you can use. We have Adobe Audition, we have GarageBand. So this GarageBand is actually built-in software that available on any Apple products, right? Like a MacBook, for example, and also iPad, right? Logic Pro X, we also have Ableton Live, Descript, Audacity, Studio One, SoundForge, and also WavePad. So these are some of sound editing tools that you can use to edit your sounds that you want to include, right, in your interactive multimedia projects, right? Okay, I think that's all for now. Thank you so much for listening, and then see you guys on the next chapter, which is chapter 6. Thank you so much. Have a pleasant day ahead, and see you again next time.